The last strategy we are going to use to find zeros of a polynomial is a method called substitution, and I also call it reduction of order because the idea is that we are going to make a substitution, okay? So we have to pick a substitution, and we choose it intentionally so that the degree of the polynomial is reduced, hence the reduction of order. But then what we're going to do is, once we make the substitution, factor, solve, okay? But then whatever we solve, it's with the new variable, so we actually need to resubstitute and then solve. So it's factor, solve, pretty much, okay? So let's see it in action, okay? You may have seen this before, but the idea is, so x to the fourth minus 5x squared plus 6 is really hard for me to conceptualize. So what I'm going to do is I say, okay, well, there's like a pattern going on here with the x's. So I might say, okay, if I let y be x squared, this might be easier for me to work with. And so then I get the polynomial y squared. Okay, this is really x squared, right? Minus 5y plus 6. And then I'm still finding where this is equal to 0. Okay, so then let's see. So I factor the result after substitution. So this is going to be y minus 2, y minus 3 is equal to 0. So then y is equal to 2, y is equal to 3. Okay. Now, the original problem, it was not a function of y, right? It was a function of x. Okay, so I was able to solve it for y, but I want my answers in terms of x. So x squared is equal to 2. So now I resubstitute. And then x squared is equal to 3. Okay, solve for each just by square rooting both sides. Okay, so x is equal to plus and minus square root of 2. X is equal to plus and minus square root of 3. And I'm done, more or less. I would just say, okay, my zeros are going to be at plus and minus square root of 2 comma 0. I could write those as two separate points if I wanted. And then plus and minus square root of 3 comma 0 for the other one. Again, writing as 2 points as needed. Okay, so that's the process of reduction of order. Make a substitution, factor the substitution, solve, resubstitute, and solve. Okay. The next one is a little interesting. I like it. But before we go ahead and make a substitution, I see that there's an x in common to everything. So this is like x squared. And then if I factor out an x squared, I'd have x to the sixth minus 6x to the third and plus 5 is equal to 0. Okay. Now, for the first chunk, I can say, okay, well, x squared is equal to 0. Okay, x is equal to 0, fine. Okay. And then I'm still working with this second piece, x to the sixth minus 6x cubed plus 5. Okay, and so I want to do a reduction of order. Let's do, I don't know, let's do a fun variable. Let's do p, okay? What is p going to be to make my life easier, okay? If I look here, this x to the sixth is x cubed squared, and I also have an x cubed over here. Maybe try p is equal to x cubed. If I do that, I get p squared minus 6p plus 5. All this is still equal to 0. And then if I factor this, this is going to be p minus 5 and then p plus 1. Oops, sorry, p minus 1 rather. Okay, there we go. Solve for p, and I get p is equal to 5, p is equal to 1, okay? But again, I'm not solving for p, I want x. So resubstitute x cubed is equal to 5, and x cubed is equal to 1, so then x is equal to the cube root of 5, and then x is equal to the cube root of 1, which is conveniently just 1, okay? So in all here, I get 3 distinct zeros. I get the point 0, 0, cube root of 5, comma 0, and 1, comma 0. Cube roots, there aren't pluses and minuses. That only happens with, the pluses and minuses only happen with even roots. So these 3 zeros are all I have and all I need, okay? But key takeaway here is this reduction of order method. So we have to make a substitution, choose it carefully, factor the result, solve the result, and then once we get it solved, resubstitute and solve again. All right, and that's all that there is to substitution and reduction of order. So we'll use these strategies along with the other factoring strategies to find the zeros of a polynomial. So let's go ahead and get to work.